I'll be getting started now. Does anyone have any questions about the previous classes? Okay. So today we'll be going over graphing and linear equations, which I will actually use this website for. It would be nice for you to follow along and practice as I talk. So we went over this in the meeting about linear equations. So this is the x-axis, this is the y-axis. And if you will want to draw a point, you first go like say 5/3. You go 5 to the x and 3 to the y. Similarly, if it's negative, you just go into the opposite direction. If you want to graph a linear equation like y equals x minus 3, so if you were to graph this out, it would give you a straight line, because every time x increases, y increases by the same amount, so it must be straight. So first, we need to find the y-intercept. So what the y-intercept is the y when x is 0. This form is convenient because it's just -3 since x is 0. So so the y-intercept is -3. The line crosses this point 0, -3 as it travels along the plane. Similarly, the x-intercept is the same with the y-intercept except for the x-intercept. So the x value on y is 0 since that's on the x-intercept. So if y is 0, then x equals 3. So you have this point. Now, so we have these 2 points, but it's a straight line. And the thing you can do here is just draw a straight line, since it's a straight line. And a straight line only needs 2 points to make rigid or to determine it. But what I mean by determine is that no matter how you draw a line through 2 points, it's always going to be the same line. So if we were to actually draw this equation out on Desmos, you can see it somewhat matches my line. I didn't really draw straight. But what if we had y plus 2x equals 6? This is not in the form of our previous equation. So for any linear equation, we can just find 2 points. Otherwise, what you can also do is convert this back to the original form we saw before. So, and then from here, you can find the x and y intercepts, or from here, you can also find the x, y intercepts. The x, y intercepts are convenient in that way. So this is called the slope intercept form or something along those lines. And the top is called a standard form, where this would be the standard form. So y equals ax, where a is some constant, plus b is slope intercept. Cy plus bx plus a equals 0 is standard form. So this form is convenient in that it's just laid out for you, the y-intercept and also the slope, which I will talk about later today. And the standard forms, everyone thinks on one side. Now there's going to be another form which I will talk about later. So now let's get into slope. So if I draw a few lines here, well, you can see my equations, but regardless. Okay, so as you can see, these lines rise and fall by different amounts. So if we were to take this copper line, it runs by 2 and goes up by 1. And furthermore, if we were to take this black line, it goes by 1 and goes up by 2. This is what we call slope. Similarly, this blue line goes for every increase in height, where height as y, and it goes right by 1. So this is slope. It's similar to like if you were walking up a slope. It's a measure of how steep a line is. So a formula for this would be m, which is what we use for slope most of the time. y2 will y2 minus y1 over x2 minus x1, where x2, y2, and x1, y1 are points on a line. So if we were to take this line, so 0, 0 is a convenient point to set as x1, y1. This point is also convenient since it's integer. So this is 3, 6. Put it through here. You get that the slope is 2, which is what is shown here. So going back to the slope intercept form. So if we had 0, 0, we would have, x equals 0. So 0 be as our first point. And let's say x is some arbitrary number c, ac plus b. Putting this back to our slope equation, we would find that the slope equals a, which is very convenient. Now I drew 2 lines here that are special in a way. This purple line and the green line. So let's take these 2 points on here. 0, 2, and 6, 2. So slope equation, m equals 6 minus 2 minus 2 over 6 minus 0 is 0. So its slope is 0. on the other hand, this line, it's vertical. So let's take these 2 points. So 3, 6, and 3, 0. So then putting this through, 6 minus 0 over 3 minus 3 equals 6 over 0. So as you can see, this doesn't, 6 over 0 doesn't really mean anything. You can call it infinity, but it's more like it doesn't exist. So a vertical line has a non-existent slope, which you could also call infinite slope. But let's say we wanted to find a line from its, find an equation from its line. So you would have a line, but not a line, but not what it actually is. So I have this box to prevent you guys from seeing what it is. Okay, so we have this blue line, and the points actually show up here, which is nice. So the first thing we could do is calculate the slope from 2 points. So we have this point, 2, 4, and and this point, 0, negative 6. So using the slope equation, we can find that the slope is 5, which is also 5 minus negative 6 over 2 minus 0. Then you can find the y-intercept, which is obviously negative 6 since its cos is here. So if we use the y-intercept form, this is the y-intercept negative 6, this is the slope 5, y equals 5x minus 6, which is actually what I had here. So why don't you guys give it a try? I'll type in something and you guys try to figure out what it is. No. What is the equation of this line in any form, really? I'll move so there's integer points. m equals 1/4 is close, but a bit off. This point's 10/4. I mean, you guys can work together. It's fine if you do. If anyone who just entered has any questions, they can ask now. Okay, so one thing we could do is find the slope. So if you plug this in, it's 1/5. The calculation should be simple, but make sure to line up the specific y and x's. This is not equal to y2 minus y1 over x1 minus x2. While you can switch these, it's easier to remember that 2 is on the left. But regardless, the intercept is where it meets the y-axis, which is 2. So we have y equals 1/5 x plus 2. Another thing we could do is that, is that after finding this point and the slope, we could, so it's 1/5 through 10/4. And that's if we pretended this wasn't very easy to write. So when x is 10, y is 4, but while the change of y is 1/5 of x is changed, which is something where referring to change as how much it would change, not how much it is changing by. As a more complex concept, y is changing by 1/5 with respect to x, but using this method of drawing this right triangle is better for now. So we can write this equation. So this would solve this condition that x is 10 while y is 4. However, it doesn't change the slope issue. This equation, if you type it in, gives a slope of 1. So what you could do, so you know that x needs to have a coefficient of 1/5 compared to y on the other side. So you can just simply times this by 1/5. This is what we call the point slope form. If you distribute this out, you will get the same equation as this. Does anyone have any questions? Okay, so a concept we should go over is that of midpoint. So a midpoint is defined as what is as a point along a line segment. A line segment is non-infinite. So something like between here and here. I think I could write it actually. Can I? Yeah. I can. Oh, that. Never mind. So just pretend these don't exist. So the midpoint is a point where the point is equally distant from both ends. So let's say this is midpoint, which we would name M for midpoint. So these two ends, A and B, AM, where this is the length of the segment, equals MB. So I went over before how to calculate distance, which is this, which is an extension of Pythagoras' theorem. But a really simple method of finding the midpoint is that, let's say, A is x1, y1, x2, y2. The midpoint would be x1 plus x2 over 2, y1 plus y2 over 2. So if we were to put this into the Pythagorean theorem, or the distance formula, I should say, you would get something like half y2 minus y1 square plus x2 minus x1 square, which is if you find out AB, which is half the distance of AB. Okay, so onwards. So I have this line here. It's in slope intercept form for convenience sake, but so lines intersect with each other. Usually, I should say. If you want to find an intersection, I should do something different, so it's harder. So we have these two equations. So we need to find a point where x and y fits both equations. So y must equal 0.2x plus 2 and 0.5x plus 3. So an easy thing to do would be to convert both to slope-intercept form if they weren't already. In this case, they are because it's easier. And then set these two equal to each other since they're both equal to y. And then you can solve x equals -1 over 0.3, whatever this comes out to. And then you plug this back into here or here. You can plug it into both to check your work, and then you can find y. However, let's take these two lines. So our original form a while ago, and then 0.2x plus 4. So these are both in slope-intercept form. However, let's say we wanted to find x or y, x because it's convenient. So 0.2x plus 2 equals 0.2x plus 4. So you can minus 0.2x from each side since it's a like term, but then you get 2 equals 4. Now 2 does not equal 4, which is obvious, self-evident. So this equation is impossible. So the conclusion you can get from this is that these two lines, green and dark blue or purple, never meet. So looking along, they go hand in hand really, but they never meet. Now these two lines are called parallel lines. So these lines are parallel because they have the same slope. If you were to go 1 to the right, or where 2, I guess, since I drew it that way, it always goes up by 0.4 on both lines, so they can never get closer to each other. And the distance between these two parallel lines never changes. The distance between line thing is essentially the distance of a perpendicular line between both lines, which I will talk about very soon. However, if we were to have y equals 0, 2.x plus 2, no 2. These are actually the same line, so they have the same slope but aren't parallel. So just watch out for that. If they're the same line, they have the same slope, but they're not parallel. Now I mentioned perpendicular lines. So I should do this for now, though I can't see. Okay, so just as a concept, if we had two lines and these two angles are equal, they are perpendicular. What we also call these angles are right angles since they form squares, and that's why squares are what they are. Their sides are perpendicular to each other, and also rectangles as a bit of an extension of that. So this line is perpendicular to these two lines. So how do we find this perpendicular lines without actually looking at the line itself? In other words, how do we find a perpendicular line to an existing line? So pretend this wasn't here. How would you find said line? Well, a common law you will see is that if this were to be line 1 and this would be line 2 with m2 as a slope and this as m1 as a slope, m1 times m2 will equal -1. I think I could prove this, but it would probably use mathematics that are way higher. So you will probably learn this if you ever wanted to pursue geometry. But as a basis, if two lines are perpendicular, their slopes product is -1. So a common exercise that you might would be to find a line that is perpendicular to a line and that travels through a certain point. So first of all, as I said before, products of slopes is -1, 0.2 times -5. So let's keep this green line. And what if we wanted a perpendicular line that went through a point? Let's say 4, 0. So we know the slope already, which is -1 over 0.2 equals negative plus, no, it's -5. So, and we know a point, so why not just use the point slope form? So y equals -5 times x minus 4. So this is the line that would become perpendicular. So drawing this out, is by a glance perpendicular. So how about you guys try it for yourself? So y equals 0.1 x plus 2. What would be a line that's perpendicular to this blue line and goes through the origin 0, 0? I'll be right back, but just answer your questions in chat. Okay, I'm back. Had to do something. Okay, so the slope of the perpendicular line is -1 over 0.1 equals -10. So we know the slope, we know a point, we can just shove it into point slope form, which actually turns out to be slope intercept form if we look closely at it. Y equals -10x. Very simple. So now we should talk about functions. So what a function essentially is a mathematical something that turns one number into another number. Really, it doesn't have to be just numbers, but something that changes something from something else. So a common comparison for this is that a machine that gives something and then you put it in and then you get something out of it. So a bean turned into a square. So how does this relate to this? So we have our function. So we need an input and an output. However, a rule about this is that an input cannot lead to more than one output. This is banned, or to say, well, it's bad. There's uncertainty. What is it? Okay, but you can have more than one input go to an output since there's no uncertainty. This creates uncertainty because you don't know which output to take from this input. So in a linear equation, x is our input and y is our output. A common way to put y is fx because f for function, x as input. So, and then you just graph it as y, and y equals fx. This would be the graph. And the fx would equal 0.1 x plus 2. So but it doesn't need to be just linear functions. It can be, say, can I type this? Y equals absolute x. It forms a v. X squared, x cubed, x4. I recommend you guys try it out and find what you see. 1 over x. So on the subject of functions, I should go over parabolas. This is a parabola. By its hard definition, it's a group of points in which a focus, which is a point, and a line, which is usually straight, but if it's terribly hard, you can make it slanted. And it's a group of points such that each point is equidistant, the same distance from the line and the point. However, I recommend you think of it as a graph quadratic, which, because it essentially is,